Hello everybody, I am Meenal Jain from Persistent Systems. Today we are going to learn about Android mobile application development under the Smart India Hackathon 2017 initiative. The key features for today's session are going to be what is Android operating system, its architecture, the various components available with Android, Android UI interface and how to develop applications on Android. Let's start. The objectives for today's session are overview of Android, environment setup, architecture, application components overview, Hello World app, application components in depth and UI interface. Android overview. What is Android? Android is an open source Linux based operating system for mobile devices such as smartphones, tablets, set-top boxes, televisions, computers, etc. Android was developed by Open Handset Alliance led by Google and other companies. In the first beta version of the Android software development kit was released by Google in 2007, whereas the first commercial version, Android 1.0, was released in September 2008. On June 27, 2012, at the Google I/O conference, Google announced the next Android version, 4.1 Jelly Bean. Jelly Bean is an incremental update with primary aim of improving the user interface both in terms of functionality and performance. The latest OS version released by Google is Nougat. The source code for Android is available under the free and open source software licenses. Google publishes most of the code under Apache license version 2.0 and the rest Linux kernel changes under the GNU General Public License version 2. The next question would be, why would we use Android? What is in Android that makes it so beautiful? Some of the reasons why we would use Android is open source. The cost of development is very less. It has a rich development environment. It is open source. Android has a large developer community which can help us in our development. Android features. What kind of features does Android provide? Android provides beautiful UI interface. It also provides connectivity to different mediums like GSM, Edge, IDEN, CDMA, EVDO, UMTS, Bluetooth, Wi-Fi. It also provides support to SQLite database, most media playback formats, messaging, browsing, multi-touch, GCM, Android Beam, etc. What kind of applications can we build on Android? Android applications are usually developed in the Java language using Android Software Development Kit. Once developed, Android applications can be packaged easily and sold out either through the store such as Google Play, SlideMe, Opera Mobile Store, Mobango, F-Droid and Amazon App Store. Android powers hundreds and millions of mobile devices in more than 190 countries around the world in various categories like music, sports, multimedia, news, etc. How do we develop these applications on Android? What kind of environmental setup is required? The system requirements for Android development would be any operating system like Windows, Mac or Linux with a minimum 3 GB RAM and a 2 GB disk space. Though for good performance we require at least 8 GB of RAM. The machine should already have Java 1.8 installed. Why should we use Android Studio? Android Studio is official IDE for Android application development. Android Studio offers features that enhance your productivity and building Android apps such as a flexible Gradle based system, a fast and feature-rich emulator, a unified environment where you can develop for all Android devices, instant run to push changes to your running apps without building a new APK, code template and GitHub integration to help you build common app features and import sample code, extensive testing tools and frameworks, lint tools to catch performance, usability, version compatibility and other problems, C++ and NDK support, built-in support for Google Cloud Platform, making it easy to integrate with Google Cloud Messaging and App Engine. We can install Android Studio on most common desktops. The latest version of Android Studio can be downloaded from Android developer website. Here we will discuss the installation of Android Studio on Windows. Similar instructions for Mac and Linux can be found on Android developer site. Before we install Android Studio, Java version 1.8 must be installed. We need to follow the instructions recommended by the installer to install Android Studio. Once Android Studio is installed, it will go ahead with configuring the environment. We need the installer gives us options to import any previous settings which might be carried over from previous installation, else it will go ahead with the fresh settings. In case we don't have any SDK installation, Android Studio will help us install one. Once the setup is done, Android Studio launches with a welcome dialog. This screen also has options to create a new application. Open an existing application, check out a project from version control like GitHub, import from previous Eclipse project or import a sample project. This would be our first assignment for the day. In this assignment, install Android Studio on your machine. Android system architecture. What does Android system architecture contain of? The Android operating system is mainly divided into 5 sections: Linux kernel, libraries, Android runtime, application framework and applications. Let us have a look at each section in depth. Linux kernel. Linux kernel provides abstraction between the device hardware and contains all the essential drivers for keyboard, camera, display, etc. and also handles networking. Libraries. Libraries on top of Linux kernel. There are a set of libraries including open source, web browser. Libraries. On top of Linux kernel, there are a set of libraries including open source web browser engine, WebKit, well-known libraries, repository for storage and sharing of application data, libraries to play and record audio and video, SSL libraries responsible for internet security, etc. It also encompasses those Java based libraries that are specific to Android development like application framework libraries, in addition to those that facilitate user interface, building graphics, drawing and database access. Android runtime. Android runtime is the third section of the architecture and available on the second layer from the bottom. This section provides key components called Dalvik virtual machine, which is kind of Java virtual machine specially designed and optimized for Android. Android runtime also provides a set of core libraries which enable Android application developers to write Android applications using standard Java programming language. Application framework layer. This layer provides many high-level services to applications in the form of Java classes. It includes key services like Activity Manager, content providers, resource manager, notification manager and view system. Android application layer. This is the layer where our applications are installed and this is the top layer. Let's look at how we can develop Android applications through Android Studio. Once we install Android Studio and the installation is successfully complete along with SDK installation, Android Studio gives us option to select or create our first application. Let us create a new application. So Android Studio gives us option to enter details like application name, package name and project location for the new application. Next, it asks us to select target devices and minimum SDK version we would like to support. Android Studio lets us select from form factors or categories or target devices for every app we create. Next, it asks us to choose a template for the main activity of the application. Select a template and click next. This screen allows us to customize the activity by creating a XML file, layout file. This layout can later be used to create UI for the main activity. Once we click finish, Android Studio will start the process of creating our application. Once you open your Android Studio, you can start with new project. It will ask you for your application name. So let us type hello world. Hello world, and we have given a package name as hackathon.example.com. Okay, it will be stored in my D drive at the given location. Let's click on next. Next, it asks us which API level we would like to select. Here you can also find help me choose. When you click on help me choose, it tells you a number of details. One is which OS you would prefer. Supposedly I choose 4.4 KitKat, it tells me that 73% of the devices support 4.4 version KitKat, and here on the right hand side I can see all the features that are supported by KitKat. Today we will start with Lollipop, that is 5.0 version 21. It supports 40% of the devices that are available today, and it supports the features that are displayed on the right. So let us click on OK. Here we have selected API level 21, that is Android 5.0 Lollipop. Here you can also select for which device you are making your application. Currently we will go ahead with phone and tablet selection. Let us click on next. When we come to next, it shows us that main activity will be created for us. We can rename this activity, say to hello activity. Okay, and activity underscore hello dot XML layout file will be created for us by the system. This is the UI for the activity that will be created. Let us click on finish. Once we click on finish, the application will attempt to create, the Android Studio will attempt to create an application for us. It takes a couple of minutes to create the application as it loads all the dependencies and repositories required to create this application. When we click on the project bar here, we can see the folder structure that is available for our application. You can click on this green triangle here, or we can click on build, or we can click on run to run our application. So let us click on run and build our first application. Here you can see that the Gradle build is in progress. We can click on this message window to check the status of our application build. Our application has been successfully built. Okay. So now when we try to run our application, one more thing it will ask you is select the device on which the application should be installed. As I have connected my phone right now and its drivers are already installed on my computer. So it is asking if I should connect to the Motorola Moto G4 device. I click on OK and it will install it on my phone. It takes some time to build your first application. You can see here at the bottom bar it shows the status of what it is doing. Right now it says it is installing the APK. Here in the message window we can see the status of our application. And in the Android monitor we can see logs for our application. Okay, so our installation is over. Let's see how it looks on our phone. So I have an application here which is mirroring my phone's screen, and there we go. Let's adjust. Okay, let us adjust the size of the phone screen. Yeah, this is good. So here we have a basic Hello World application with 3 tabs: Home, Dashboard and Notification. So we have created our first application and installed it on our device successfully. Let's move ahead with our presentation. The next assignment for today is create your first Android application and have a look at the folder structure. Now that we have created our first application, let us see at the Android Studio user interface. There are various controls present on Android Studio. The first is Toolbar. Toolbar lets you carry out a wide range of actions including running your application and launching Android tools. Navigation bar helps you navigate through your project and open files for editing. It provides a more compact view of the structure visible in the project view. Editor window is where you create and modify code. Depending on the current file type, the editor can change. For example, when viewing a layout file, the editor displays a layout editor. The tool window bar runs around outside of the IDE window and contains the button that allow you to expand or collapse individual tool windows. The tool windows give you access to specific tasks like project management, search, version control and more. You can expand them and collapse them. The status bar displays the status of your project and the IDE itself, as well as any warnings or messages. Android intelligently allows code completion for Java as well as XML files. It also supports version system like Git, GitHub, CVS, Mercurial, etc. It supports the Gradle based build system along with build category configurations. There are many more features supported by Android Studio. A detailed documentation can be found on Android developer website. This is how an Android project structure looks like. Each project in Android Studio contains one or more modules with source code files and resource files. Types of modules include Android app modules, library modules and Google App Engine modules. By default, Android Studio displays project files in Android project view as shown here. This view is organized by modules to provide quick access to project's key source files. All the build files are visible at the top level under Gradle scripts, and each app module contains following folders. Manifest. It contains the Android manifest.xml file which defines the fundamental characteristics of the application. Java. It contains the Java source code files including JUnit test code. RES, resource files. It contains all non-code resources such as XML layouts, UI strings and bitmaps. Build.gradle is an auto-generated file which contains compile SDK version, build tools version, application ID, minimum SDK version, target SDK version, version code and version name. The Android project structure on disk differs from flattened representation. To see the actual structure of the project, select project from the project drop-down. We will look at how the project folders need to be organized in more details in next few slides. Resources. Apart from coding for the application, there are various other resources like static content that are code uses, such as bitmaps, colors, layout definitions, user interface, strings, animation instructions, etc. These resources are always maintained separately in various subdirectories under the RES directory of the project. Most of the names are self-explanatory. For example, Anim folder holds XML files which define various animation properties used in the application, and these properties are accessed from r.anim class. Similarly, color folder holds XML file that define the state list of colors. Drawable folder contains image files like PNG, JPG, GIF or XML files that are compiled into bitmaps, state lists, shapes, animation drawables. Layout folder contains XML files that define user interface layout. Menu folders contain XML files that define application menus such as options menu, context menu or submenu. Raw folder contains arbitrary files to save raw files. Value folder contains XML files that contain simple values such as strings, integers and colors. XML folder contains arbitrary XML files that can be read at runtime by calling resource.getXML. In Android, we can also provide alternative resources to support specific device type. For example, we can create drawable-HDPI folder which will hold drawables for HDPI specific Android phone. Let's have a look at all the folders that we have seen above in the above slides in our application Hello World. So, when we click on the project, okay, this project window opens up and we have the application folders here. Inside the app, we can see manifest, Java and resource folders, and then below here we have a link for all the Gradle scripts. Okay, the manifest holds our Android manifest.xml. The Java folder holds the Java files that we require for Android for our application, and the resource folder holds all the folders that are required as resources. Let us have a look at each of them individually. Now, inside Java we can see com.example.hackathon.hello-world. Under this package we have our Hello World activity. So, this is our Hello World activity. If we go to manifest, we can see all the details that we need to enter into the manifest file. So, the manifest folder has the Android manifest.xml. When we come down to the resource folder, here we can see multiple folders. Let us start with drawable. Drawable, in this particular example, this sample has been created by the system, and in this particular example we can see that in the drawable an XML file has been created. These files basically define how the application will behave, how the tab buttons will behave when we click on them. Okay, when we go to layout, we can see our activity underscore hello.xml. In this activity underscore hello, we can see a text view inside a frame layout. So, this text view is the one that we see where this text view is inside the layout that we will keep changing every now and then. The three tabs are defined under the menu folder in the navigation.xml. Here we can see our three tabs, the home, dashboard and notification tab. The mipmap contains our launcher images. So, basically these are the part of the application icon which we can see on our phone before we click on the application. Next is the values folder. In values we have colors, diamonds, strings and styles. If we click on color, it basically defines the various colors that are being used by this application. We have two shades of blue and a shade of pink. Dimension basically defines your integer values for any kind of dimensions, for your margin, padding or a particular width and height that you would like to give to your widgets. Once you go to string, here is where your strings are defined. Okay. So, this is the hello world string which is your application name, home, dashboard and notification. If we go back to our navigation.xml, we have not directly used these strings, but we have referenced them. So, this is title underscore home, which when we come to strings.xml, we can find here title underscore home, and then comes our styles. Okay. So, in the styles we can define various styles that require for our application of about the look and feel of how any widget or a particular screen might look. Below we have Gradle scripts. Now build.gradle under module app is the one that references our application. If you remember, we had selected minimum version as 21, that was Lollipop, and our target version currently it is holding as 25, which is the latest one. So any application which runs Lollipop or any above operating system will be able to support this application. Here version code is important when we are going to publish our application on Google Play Store. The version name, this is what our current application version is. This changes according to our requirement. These are the basic UI libraries that the system has added. One is the app compat and the one is design. From Lollipop, basically Android has started supporting material design, and these are the libraries relevant to material design. These are the basic settings and folders that are required for our application. Let us go ahead and have a look at the basic Android components. Let us have a look at key components of Android. We will start with activities. An activity represents a single screen with a user interface like a window or frame in Java. Like in Java, an application entry point is main method. Similarly, in Android, the entry point for an activity is onCreate method. Let us have a look at the life cycle of an activity. When an activity is created, callback methods like onCreate, onStart, onResumed are called. Similarly, when an activity is pulled down, methods like onPause, onStop and onDestroy are called. OnCreate is the first callback and called when the activity is first created. OnStart is called when the activity becomes visible to the user. OnResume is called when the user starts interacting with the application. OnPause is called when the current activity is being paused and the previous activity is being resumed. The paused activity does not receive user interface and cannot execute any code. OnStop callback is called when the activity is no longer visible. OnDestroy is called before the activity is destroyed by the system. We also have an onRestart callback. It is called when the activity restarts after stopping it. An application can have one or more activities without any restrictions. Every activity we define for our application must be declared in the Android manifest.xml file. The main activity or the entry point activity for our app must be declared in the manifest with an intent filter that includes the main action and the launcher category. Let us have a look at how the manifest looks for the main activity. As you can see here, the activity entries are made in the manifest file with the main and launcher intent filters declared. Try to create a simple Hello World app and see what sequence these methods are called. The next important component for Android is services. A service is a component that runs in the background to perform long-running operations without needing to interact with the user, and it works even if application is destroyed. A service can essentially take two states, started and bound. A service is started when an application component such as an activity starts it by calling start service. Once started, a service can run in the background indefinitely, even if the component that started it is destroyed. A service is bound when an application component binds it by calling bind service. A bound service offers a client-server interface that allows components to interact with the service, send requests, get results, and even do so across processes with inter-process communication. Like activity, even a service has a lifecycle callback methods that can be implemented to monitor changes in the service state, and we can perform work at the appropriate stage. The diagram on the left shows the life cycle when the service is created with start service, and the diagram on the right shows the life cycle of the service it created with bind service. OnStart command is called when the method onStart command is called when another component such as activity requests that the service be started by calling start service. On bind is called when another component wants to bind the service by calling bind service. On unbind is called when all clients have disconnected from a particular interface published by the service. On rebind is called when new clients have connected to the service after it had previously been notified that all had disconnected its unbind intent. On create is called when the service is first created using on start command or on bind command. This call is required to perform one-time setup. On destroy is called when the service is no longer used and is being destroyed. Your service should implement this to clean up any resources such as threads, registered listeners, receivers, etc. Like activity, every service entry must be made in Android manifest file. Broadcast receivers. What are broadcast receivers? Broadcast receivers respond to broadcast messages from other applications or from the system itself. These messages are sometimes called events or intents. For example, applications can also initiate broadcast to let other applications know that some data has been downloaded. The broadcast receivers intercept these communications and will initiate appropriate action. An application must create a broadcast receiver and then register with system to receive broadcasts. System events that a receiver can listen to are battery status call. An application must first create a broadcast receiver and then register with the system to receive broadcasts. System events that a receiver can listen to are battery status, call status, and system boot status. An application can also send custom broadcast messages by invoking send broadcast method. An application listens to specific broadcast intent by registering a broadcast receiver in Android manifest file. When an application wants to send a custom broadcast, the broadcast intent must be registered in the manifest. Content providers let you centralize content in one place and have many different applications access it as needed. A content provider behaves very much like a database where you can query it, edit its content, as well as add or delete content using insert, update, delete and query methods. In most cases, this data is stored in a SQLite database. The content provider is implemented as a subclass of content provider class. To query a content provider, you specify the query string in the form of the URI, prefix, authority, data type and ID. Prefix is always set to content ://. Authority specifies the name of the content provider. For example, browser, contacts, etc. For third-party content providers, this could be a fully qualified name such as com.tutorialspoint.statusprovider. Data type indicates the type of the data that this particular provider provides. For example, if you are getting all contacts from content provider. ID specifies the specific record requested. For example, you are looking for contact number 5 in the content provider. Fragments. Fragments are most important part of an application. A fragment has its own layout and its own behavior with its own lifecycle callbacks. We can add or remove fragments in an activity while the activity is running. Multiple fragments can be combined in a single activity to build a multi-plane UI. A fragment can be used in multiple activities. A fragment lifecycle is closely related to lifecycle of the host activity, which means when the activity is paused, all the fragments available in the activity will also be stopped. A fragment can implement a behavior that has no user interface component. Prior to the introduction of fragments, there were limitations because there can be only a single activity on the screen at any given point in time. So it was easily possible to divide the device with fragments. It is easily possible to devise. So it was not easily possible to divide device screen and control different parts separately. But with the introduction of fragments, gives the screen design more flexibility and removes the limitation of having a single activity on the screen at a time. Even now, there can be only one activity on the screen, but each activity can comprise of multiple fragments, which will have their own layout, events, and a complete life cycle. The image shows a typical example of how two UI modules defined by fragments can be combined into the activity for a tablet design but separated for a handset design. The application can embed two fragments in activity A when running on a tablet sized device. However, on a handset size screen, there is not enough room for both fragments. So, activity A includes only the fragment for the list of articles, and when the user selects an article, it starts activity B, which includes second fragment to read the article. Let us have a look at the life cycle of fragments. Fragments have various callback methods like onAttach, onCreate view, onActivity created, onStart, onResume, onPause, onStop, onDestroy, onDetach, etc. OnAttach, the fragment instance is associated with an activity instance. The fragment and the activity is not fully initialized. Typically, you get in this method a reference to the activity which uses fragments for further initialization work. OnCreate is called by the system when creating the fragment. You should initialize essential components of the fragment that you want to retain when the fragment is paused or stopped and then resumed. OnCreate view is called when it's time for the fragment to draw its user interface for the first time. To draw a UI for your fragment, you must return a view component from this method, that is the root of your fragment's layout. On activity created, the activity created is called after onCreate view method when the host activity is created. Activity and fragment instances have been created as well as the view hierarchy of the activity. At this point, view can be accessed with the findViewById method. Example, in this method, you can instantiate objects which require context object. OnStart method. The onStart method is called once a fragment gets visible. OnResume fragment becomes when the fragment becomes active. OnPause. The system calls this method as the first indication that the user is leaving the fragment. This is usually where you should commit any changes that should be persisted beyond the current user's session. OnStop fragment will stop. OnStop fragment is called when the fragment is going to be stopped. Fragment view will destroy after calling the onDestroy view method. OnDestroy. OnDestroy called to do final cleanup of the fragment state but not guaranteed to be called by the Android platform. An Android intent. Intents and filters. These are also an extremely important component for Android development. An Android intent is an abstract description of an operation to be performed. It can be used with start activity to launch an activity, broadcast intent to send it to any interested broadcast receiver components, and start service intent or bind service intent to communicate with background services. There are separate mechanisms for delivering intents to each type of component. Components like activities, services, and broadcast receivers. Intent object is passed to context.startActivity to launch activity or to get existing activity to get to do something new. When an intent object is passed to context.startService to initiate a service or deliver new instructions to an ongoing service. Context.sendBroadcast is used to deliver a message to all interested broadcast receivers. Next, we are going to learn about intent objects. Now, what is an intent object? An intent object is a bundle of information which is used by the component that retrieves the intent as well as information used by the Android system. An intent object can contain the following components based on what is communicating or the action to be performed. This is a mandatory part of intent object and is a string naming the action to be performed, or in case of a broadcast intent, the action that took place and is being reported. The second important component is data. Data adds specification to an intent filter. The specification can be just a data type or a URI, or both a data type and a URI. The other optional components for intents are categories, extras, flags and component name. Intents are mainly of two types, explicit and implicit intents. Explicit intent is used to connect the internal world of applications, like one activity calling another activity. Implicit intents do not name a target, and a field for the component name is left blank. Implicit intents are often used to activate components in other applications. For example, these intents are used to open other applications like contact directory, calendar, or any custom application which conforms to the intent definition. We use intent filter elements in the manifest file to list down actions, categories and data types associated with any activity, service or broadcast receiver. It helps other applications when they fire an implicit intent to invoke this application. Let's have a look now at the demo. Okay, now let's have a look at the various application components that we have seen. Let's go back to our hello activity. In hello activity, you can see the onCreate method has already been created when we created the activity. This method is the most important method as far as an activity is concerned. If we go to android.manifest, here under activity tab, we have mentioned our activity, okay, and we have marked its intent filters as action main and category as launcher. Basically, this tells our application that whenever the application is launched, it should launch using hello activity. Hello activity becomes our entry point to the application. Suppose we want to create another, let's say we have one hello activity, okay, and now we would like to jump on to another activity. So, we create another activity, okay, which is say a fragment activity. So, let us just go ahead and create a basic activity. Okay, this is going to be our second activity. Now, when we start creating this activity, what it tells us is it is going to create an activity underscore second.xml for this particular activity. Okay, this is not our launcher activity and we will be using fragments in this activity. Okay. Its hierarchical parent would be AppCompact library. Okay, and this is the, let us remain in the same package name. You do a finish and the second activity will be created just here. Now, we can see this second activity. So, here we have created a second activity which extends AppCompact activity, okay, and here we have set content view r.layout.activity second. So, basically we have tied up this activity with our activity underscore second.xml layout. When we go to activity underscore second, we can see that some design has already been created for us here. So, we have a floating action button on this because this is one we picked up from the samples that are given, and we have a app bar layout also given on this. How do we invoke this second activity? So, let us go to our hello activity. Okay, we go to our hello activity. Along with this text view, let us create a button. Android ID, say button 1, we will keep a width as wrap content layout width, we will mention the layout height, again as wrap content for now, and we will mention a text. We can directly mention texts here, but it is a good practice to give it in strings.xml. So, we say text as click. We go back to our hello activity. Here we will create a reference to our button. So, button m button 1 is equal to find view by ID dot button 1. Let's add the package and let's cast this class cast exception. Then we have mbutton dot set on click listener this. Now, when we say this, we will have to implement this on click listener. Okay. So, as you can see, the ID is pretty intelligent and it gives us most of the methods. Okay. So, let us go to our second activity. For this, we will first have to create an intent where we specify which activity we would like to invoke. So, that is intent, our hello activity, and we want to create our second activity. And then we say start activity and intent. So, let us run this application and see whether our second activity gets invoked. So, we go here and we run our application. Okay, so let us see, our application is installed and we have the click button here. Okay, when we click on this, it will take us to the second activity. Okay, we can see this floating button out here, which was there part of the second activity. If we go back from here, it will remove the second activity from the stack and we will be able to see our hello world once again. Now, let us go back to our activity underscore hello. What is it? Okay, it's the frame layout. It's a frame layout. So, now you can see that our text view got overlapped with our button. So, let us add a linear layout here. Okay, there is a linear layout. Width is going to be match parent and height is going to be wrap content and its orientation is going to be vertical. We take this tag, we go below the button, okay, and there we go. So, now if we run our application again. Okay. Now when we run our application again, we can see the home and the click button. Now let's have a look at how to create fragments. So here we have created, let's create a fragment. We can go here and we create a fragment with a list. So it's going to be an item, let's say item fragment 1. It will create a layout file called fragment underscore item, and it will also, because we have gone for a list, it will also attach a recycler view adapter to it. Let's click on finish. Now as we can see here, it has created the basic structure for the fragment for us, along with how we will be accessing the list as well. Okay. Now we go back to hello activity. We need to replace this frame layout with our newer fragment. So we go to hello activity and let's say on click we will create our new activity now. Let's comment this out and create a newer activity. Okay, now that we have seen how intents work to invoke another activity, let's go ahead and check out how the fragments work. So this is the code of how the fragment will work. To start with, we first need a fragment manager, which will be provided by the activity itself. Second, to start any kind of fragment transaction, we need a fragment, we need reference of the fragment transaction. Okay, and then we need to replace the current content window with the next fragment. For that, we have created an object of item fragment 1, and we have replaced the ID content which we had seen in our activity hello. So this frame layout content will be replaced by the new fragment. Okay, and then once we are done with our replace, we do a commit transaction to executing the replacement of this fragment. Let's run and check if we can see the list once we click on commit. Let's see. Okay. Okay, let's go and check our application of how it looks. We go here and we click on it. Oh, the application has crashed. So if we now go to Android monitor, we can see why our application has crashed. Okay, it says we need to implement on list fragment interaction listener. Okay, we need to implement it here. Okay, let's see now it runs. Let's click on this and there we have. Okay. Okay, so let's have, now that we have run our application, let's click on click, and the second transaction has been replaced by the first one. Now because these are part of a stack, we have fragment 1 on top of fragment 2, because of which we can see the home and the click label from the previous fragment. The best way to do it would be, if you want to maintain the stack, one thing that we can do is we can make our activity background as opaque. So, let us go back to fragment item list and make our background a solid white. Okay. We click on click and let us see, yes. Now, this is our list which we can scroll and come back. So, this is the basic example of how our activities and our fragments would work. Next, we move on to the UI interface available with Android. Android provides rich UI interface components to develop UI rich applications. The basic building block for any user interface in Android is view object, which is created from the view class and occupies a rectangular area on the screen and is responsible for drawing and event handling. View is the base class for widgets, which are used to create interactive UI components like buttons, text wheels, etc. The view group is a subclass of view and provides a visible container that hold on views or other view groups and define the layout properties. At the third level, we have different layouts. Android has a number of layouts that we can use. The most common layouts are linear layout, relative layout and a web view. Linear layout aligns object horizontally or vertically in sequence depending on its orientation. A horizontal layout will align objects horizontally, whereas a linear layout or a vertical layout, whereas a linear layout with vertical orientation will align objects vertically. Relative layout aligns view object relatively depending on other views in the layout. Web views are basically used to display web pages or HTML code. We have some additional views as well, like list view and grid view. List view aligns object in form of a list. Similarly, we have grid view, which aligns view objects in a view. Layouts have a set of attributes which define the visual properties of the layout. The most commonly used attributes are ID, layout width, layout height, etc. These attributes define the look and feel of the attributes. The ID attribute gives a unique identity to a view, which is used to access it in the Java source code files. Android provides a number of UI controls to perform various actions. We will discuss most commonly used UI controls in Android. A text view. Text view is a controller used to display read-only text. Edit text is a controller used to enter text. Button is a push button that can be pressed or clicked by the user to perform a certain action. A checkbox is an on-off switch that can be toggled by the user. Toggle button is an on-off button with a light indicator. The radio button has two states, either checked or unchecked. The progress bar view provides visual feedback about some ongoing tasks, such as when you are performing a task in the background to fetch some data from the server. There are numerous views that are provided by Android, like spinner, time picker, which helps us open the clock, date picker, which helps us open a calendar view, etc. A full list of controls can be found on the developer website. The progress bar view provides another important feature for a user interface is event handling. Events are a useful way to collect data about a user's interaction with interactive components of applications. For example, a button press, on button press, event management has events are a useful way to collect data about a user interaction with interactive components of applications. For example, a button press. Event management has three basic concepts: event listeners, event listener registration, and event handlers. An event listener is an interface in the view class that contains a single callback method. These methods will be called by the Android framework when the view to which the listener has been registered is triggered by user interaction with the item in the UI. Event registration is the process by which an event handler gets registered with an event listener, so that the handler is called when the event listener fires the event. When an event happens and we have registered an event listener for the event listener calls the event handlers, which is the method that actually handles the event. Let's discuss a few more commonly used event listeners and handles. On-click and on-click listeners. On-click and on-click listeners is used when the user either clicks or touches or focuses upon any widget like button, text, image, etc. On long click listener is used when the user either clicks or touches or focuses upon a widget like button, text, image for 1 or more seconds. On focus change listener is used when the widget loses its focus or gets a focus, that is, user goes away from a view item or enters into that item. On touch listener is used when the user presses the key, releases the key, or any movement gesture on the screen. On menu item click listener is called when the user selects a menu item. You will use on menu item click event handler to handle such events. On create context menu and its listener is used when the context menu is being built as a result of sustained long click. The last assignment for the session is create an application which has a splash screen and a login form. When the user clicks on the login form, the user should be able to see dashboard page. The dashboard contains a set of images which can be displayed in a list or a grid format. Let's look at a few more concepts that are available with Android. We have a resource called as style. A style resource defines a format and look for the UI. A style can be applied to an individual view from within a layout file or to an entire activity or application from within the manifest file. Style.xml file resides under the resource value folder. We can define multiple styles per file using style. We can define multiple styles by using the style tag, but each style will have its unique. We can define multiple styles per file using the style tag, but each style will have its name that is uniquely identified by the style. Styles can then be applied to view components in layout files. Sometimes there is a need to do more than standard components currently defined. So Android provides you with the means of creating your own custom components which we can customize to suit our needs. If we need to make small adjustments to the existing widget, we can simply subclass that widget and make the change. Else the developer can also create a completely new custom view. Android OS supports notifications. A notification is a message we can display to the user outside of our application's normal UI. When we tell the system to issue a notification, it first appears as the icon in the notification area. Android location APIs make it easy for us to build location-aware applications. Without needing to focus on the details of the underlying location technology, it becomes possible with the help of Google Play services, which facilitate adding location awareness for our app with automated location tracking, geofencing, activity recognition. To use services like GCM and Google Play services like Google Maps, we need to register a project on the Google console, which provides us with important API keys and rights to access these features from Google. We can also send emails from our application but we don't need to implement a whole email client from the beginning. We can use the existing email clients that are available on the Android device by invoking the required intent. We can invoke applications like Gmail, Outlook, K9 Mail or Android Mail to send emails. Android provides built-in application for phone calls. For occasions, we may need to make a phone call through our application. These are the few concepts that we have learnt about Android today. There are many other applications there are many other components available with Android for geolocation, for maps. Now let's go ahead and have a look at the various UI components that are there. Now let's have a look at the various UI components that are available with us. Okay, so here we will be basically referring to our layout files. Let's go back to our activity_XML file. Okay, now let's have a look at the other UI interface components that are provided by Android. Let's start with linear layout. So we come back to our activity_hello.xml. Here we have a frame layout. This is basically the fragment container which gets replaced every time we put a fragment on top of it. Next we came to linear layout. Linear layout is one of the most fundamental layouts available with Android. Now here initially we had kept our orientation as vertical. Now let's keep our orientation as horizontal. As far as this text view is concerned, currently because we have given width as match parent, you can see here that it is occupied the whole width, because of which our button is not visible. Suppose now we change its orientation to wrap content. In the left side view, that is part of a preview, when an XML file is shown, we can have an approximate look of how our screen is going to look like. So here now we have the home and the click button next to each other. If I make this as vertical, you can see they have come one below the other. So that is how the linear layout works. Supposedly I go with relative layout. So I have a relative layout. Okay. Now in relative layout, I have to make sure that I position each and everything in relation with the other components. Now because we have not mentioned any kind of a relation, the click button has overlapped the text view. So what we will say here is, let's say layout below, we have to keep the ID of message. Now you can see when we said it should be below the message text view, it has come below. Align parent bottom and true, and here we can see the home is presented on top and check is present at the bottom of this whole linear layout. When you click on any one of these, we can see the area that they are occupying and where they lie. Okay. The next thing that we will have a look at is the drag and drop design that is available. Okay. So at any UI layout file, we will have two options. One is the design and other is the text. When we are working on the text, format, we can have a look at the preview here. But now if we go to the design, what we can see out here are various components that are available with Android. We can drag and drop these according to our requirement. Supposedly, so let's go to a text and say I take a plain text and I want it below home. Okay. Now you can have an ID here, so it is taken its ID as edit text. You have wrapped its width, you have wrapped its height. Let's put it as match parent. Okay. And then we have put it as, we have input type as text. Okay, so these are the different kind of input types which we can specify. Accordingly, it will open the keyboard for us. Okay. Oh, sorry. There we go. Let's put it as plain text. Okay. Now, if we go back to text, we have an edit text. where it says align start with message and below message. Okay, input type is text and this is match parent. If we want to beautify it a little more, we can give it some padding, say 5 dp. Then some margin, layout margin of say 5 dp. Okay. Now we run our application and see how our text box looks like. There we go. And here our text box looks as name, and let's just say I say it as. Okay, so when I click on name, it basically gives me a key, it opens up a keyboard and I type say Meenal, and I type Meenal on it. So this is the key edit text box that we have from Android. Okay, suppose I want to extract its value, then it's again very simple. We go back to our hello activity and we say m edit box equal to find view by id r.id dot edit text. This is going to be edit text and we'll have to cast it. Let's cast it to this, and then on click okay, so now that we've created our edit box, let's check how we can get its values of the edit box, how we can use our edit box. So we have created a string here called zest, and then we will replace the m text message to whatever has been typed in our edit box. Let's play this. Let's run this application and see how it works. Okay, let's see how it works. So when I clicked on it, it says name and name. So supposedly I change the name to hello and I do click, and you can see that it has gone to hello. So that is how you can use your edit text. Similarly, if you go back to design, you can drag and drop different kinds of layouts that are available. You can also use image views. So say we drag an image out here, you go to image and you say you want an image button somewhere here. Okay, once you have placed this here, if you go back to the text, okay, it's asking for say we selected an arrow button. Okay, we go to text here and you can see that an image view has been placed. Okay, margin top has been given as 100, that is the reason for this whole gap, and then there is a margin start, and then we can see the arrow here. So if we run this application, we will be able to see this arrow on the screen. Application has run, and here is the arrow that we had created. On this same arrow we can keep on, so basically for all of these widgets, this home, there is this button, there is this click, we can do a set click listener on these, and these will respond whenever a user clicks on this. We can perform actions on these. we have seen can perform action. We go back to design. So basically here we have a lot of components that are given from Android. You have different kinds of layouts that are available that you can use. So basically you have a constraint layout, you have grid layout, you have linear layout, we have relative layout. We can go to containers. We have seen list view in our fragment before. They also provide expandable list views. There is a grid view, we have horizontal scroll view, we have vertical scroll views. We also have web views where we can actually put our HTML content. Images can also be used in three ways. One is your image button, image view and a video view. In case of date, whenever you use these date pickers, when you click on it, it opens up your system date and time pickers. You can define your own custom ones, but by default it can open your time picker and the date picker can open your system date and time clock. If you go to Google, you can also use a map view. So basically when you have a view like when you use map view, you can invoke Google Maps on this. Okay. As far as so basically these are the main UI components that you will be using mostly. Other than that, Google also provides a lot of other components in its advanced view. You have a texture view, you can have surface views. Then you can use some design components like tab layouts, you have nested scroll views. Basically Android basically provides a lot of UI components to develop your rich applications. If we go to our project structure, all the layouts that we have created we can see out here. These are all the layouts that we created time and again for our current demo. These are our Java files that are there, that are created. We can create strings out here and then reference them in our Java applications, which we have time and again used here. So this is how a basic Android application is going to work. Now it is up to you how you can use Android efficiently and how best UI we can create out of it. Android provides all the framework and basic components that are available for creating rich UI efficient applications. We have come to the end of today's session. Today we learnt about Android operating system, its architecture, the key components available with Android, the UI interface and how to develop applications with Android. You can ask questions in the comment section below. In case of any queries, we'll try to answer as many as possible. On the internet you can find loads and loads of material for Android application development. Please go ahead and develop rich UI applications with Android. Thank you.